Hello folks, we are back with the next video. We discussed in the last video probably we did till problem number 15. Now we'll take the problem number 16 and 17. Both are exactly identical actually. Only there is a difference between sine and cos. So we'll be taking, and that also simpler problems. Why? Because the intervals are being given. So it's only for us to check whether how it is behaving in that interval. So let's quickly take that question number 16, which says that f of x is log sin x, and they give us the intervals. So let's take 16th problem. F of x is log sin x, function of a function. That's okay. Now by now we have got used to it. Function of a function. F of x is log sin x. They give us the intervals, and there you have to tell how it is behaving. So obviously we are going to take the next step, and the next step is about the derivatives. So let's take the derivative of this f dash x. First, the derivative of log x we all know is 1 by x. So first let's take the derivative of the outermost function, then we will take the derivative of the next function. So derivative of log x is always 1 by x. So also derivative of log sin x will be 1 by sin x. Now, because sin x is not a simple x, it's a function, so you have to write the derivative of that also. So derivative of sin x is cos x. So that way the overall derivative comes out to cot x. It's only that much. Now that's it. Now we don't have to hunt about the critical point and all, because they have already given the interval. They have told us, they have given us two intervals, and they're asking us in these two intervals how the function is behaving. We have to find out. So right away we can take those intervals and we can check how it is behaving there, and we can judge as to how whether it will be increasing or it will be decreasing. So as usual, we can take probably these three columns. First we call the intervals, then we call the sign, and then we call the nature. So first is the interval, then sign of f dash x, and in that interval, and the nature of the function, the nature of fx. We'll decide that depending on it. So let's go through the question. What does the question say? Prove that the function f given by f of x is log sin x is strictly increasing on 0 to pi by 2 and strictly decreasing on pi by 2 to pi. So those intervals are clear to us. The very first interval is 0 to pi by 2. So since we have to take on this interval 0 to pi by 2, so let's take any value in between pi by 4 or anything. So probably if you could take at pi by 4, then it is like cot pi by 4 we all know is 1, which is greater than 0. So here the function is increasing. So also the next interval that they tell us is pi by 2 to pi, and there again they ask us to check whether it is increasing or decreasing. In fact, they ask us strictly increasing, so yeah, strictly increasing you can write. So also between this you can take any value. 2 pi by 3 and 3 pi by 4 are the values that we generally take. That works good. So maybe 3 pi by 4 if you want, you can take f dash at 3 pi by 4. So that will happen to be cot 3 pi by 4, which you can always write it as cot pi minus pi by 4. Please check. Pi minus pi by 4 is 3 pi by 4. So because it is in the second quadrant is a quadrant only for sine and cosec, so all other ratios are going to be negative. That way this is going to be minus cot pi by 4, which is minus 1, and that is less than 0. That's how in this interval it becomes strictly decreasing. Of course we knew it because it's given in the question. The question is a prove that question, where they ask us to prove that it is, I hope it's correct, yeah, they ask us to show that it is strictly increasing on the first one and strictly decreasing on the next one. So that's how it is. Pretty simple. So the next question is exact replica of this. Only thing is that the sign is getting replaced by cos. Hardly anything to do. So let's proceed. The next is again, let's read through before going. Prove that the function f given by f of x equal to log cos x is strictly decreasing on 0, just the opposite, strictly decreasing on 0 to pi by 2 and strictly increasing on pi by 2 to pi. Exactly same steps. Let's follow. So right away, f of x is log cos x. So log cos x means when we take the derivative, it will come to the derivative of log of any function is going to be 1 by that function. So that way it is going to be 1 by cos x, and because cos x is a function by itself, so you have to account for its derivative. Derivative of cos function is minus sine. So like that this comes out to minus tan x. The f dash x comes to minus tan x. We don't have to hunt for the critical points because the intervals are given and they have asked us to check the function's behavior in that interval. So we will directly, like here, we will get these columns, etc., and check how it is behaving there. Quite easy actually. Same, exactly same steps. Here we have interval, and here it is sine of f dash x. Then this is nature of fx. So again here they give us the interval from 0 to pi by 2. So f dash is like before only. Pi by 4 if you want you can take. Then it is minus tan pi by 4. Tan pi by 4 we all know is 1. So this is a minus 1 which is less than 0. So then in that case, in this interval it is definitely strictly decreasing. Strictly decreasing. Why? Because this value came out to be less than 0. So also let's go to the next interval. They have told us the interval between pi by 2 to pi. So let's go to that interval. And what do they tell in that interval? We will find out, like you can take this. Generally we'll take 2 pi by 3 and 3 pi by 4. Generally those are the values. 2 pi by 3 means it's 120 degree and 3 pi by 4 means it's 135 degree. Generally in that range we will take. So we'll have f dash maybe at 3 pi by 4. So that means it's maybe tan 3 pi by 4, which we can always write it as tan pi minus pi by 4. It's the same. Second quadrant is a quadrant only for sine and cosec. All other ratios are going to be negative. So it's minus of, already that minus is there, that we have written. But because it's in the second quadrant, it becomes minus tan pi by 4. Minus and minus, they become plus. And tan pi by 4, we all know is 1, which is positive. That makes this strictly decreasing here. Sorry, strictly increasing here. That's all, right? So that's about this problem where they tell us that they tell us the interval and they ask us to find this. So though these are two small problems, we'll not do the next problem in this video. We can move over to the next video and there we can do the next problem. Thank you.